Welcome everyone. I'm sorry not to be there with you today. So this started as an internal seminar among PhD students, but given the interest in the topic, we decided, following a suggestion by Professor Risser, to make it like a formal, actually a formal seminar of the PhD program and open to everyone interested, of course. And so it's a pleasure to have Dario Righelli here with us today, and he's a postdoc in our department. He has a background, I think, in computer science and in coding and application in genomics in general. And so he will share his insights in this aspect of making reproducible research through building our packages. And so it's very important nowadays to make our research reproducible. So I'm leaving the floor to you, Dario, and thank you for being with us.
Thank you. Pietro, do you want to say something?
Yeah, I just want to point out that as Professor Sartori just said, this now is an official seminar of the department, but started as a beginning as an internal seminar for PhD students and postdocs, because yes, from this semester, as the majority of you know, but somebody here is new, we have an internal set of seminars called Helio, explained like I'm an undergrad. And that's something that started as an experiment this semester, but is having very good feedbacks. So I think we will expand it next semester, next year. We have new ideas and we are working on it. But so far, it's just a weekly meeting. And if you want to know something more, and if you want to join or present something, I'll give you a link here, and then you can just type it in and discover something new. And then I think that starting for next semester, we're going to activate also some sort of mailing list so we can reach out to more people. Thank you very much. And thank you.
Okay, I think that we can start. I can share my screen. Okay, let's hide this. This one. Okay. Okay. So thank you everyone for inviting me and to be here. So as just Nicola explained, I'm a postdoc here at the department in the Davide Risser's lab. We work mostly on bioinformatics, on omics data analysis, so sequencing. But by doing so, I developed several packages for doing this. And so today I will share some of the tools and the best practices that you can use for developing our packages. So let's start with a brief introduction about reproducible research from a computational side, because it's very important that when you publish a paper, or even if you just do an analysis, it's good for third parties, people, to reproduce your findings, so your results. And the main idea of this workflow that you're looking here is that we mostly start from a set of raw data. From this raw data, we do our analysis in R, for example. And from this code, we produce plots, tables, and also processed data here. Finally, we just put all together and hopefully we publish a paper. But what if we are able to produce together with the paper also supplementary materials like reports of our analysis? And when I say reports, I say that we can add natural language together with the code and together with the results that we produce during our analysis. And as we are not just analysts, we are also statistical model developers. We are interested in that other people to use our models, and to do so, we can produce our packages, and so it's easier for others to use our own models. And we also share all our knowledge and also all our code, and possibly also our data, raw data and processed data, together with our analysis and our and the main idea is that the final reader of a paper or of our report, so a collaborator, a team worker, or a friend, even a friend, can reproduce entirely our analysis by backtracking everything that we made so far. So this is the main overview of what we are touching today. So we start from our Quran repository, our studio, devtools, Roxygen, rmarkdown, testthat, Git, and GitHub Actions. And we will see very briefly every of these components all together to create and facilitate the R package, the creation for us. So first of all, I will say, we were discussing this with Pietro briefly before this meeting, before this seminar, is that you don't have to judge your code. Any kind of code is okay. You will have feedback from your community, and it's better to ask for feedbacks from your community. It could be a friend, a supervisor, everyone, and having even a line of code is better than having no code at all. So one of the main things that could be useful while developing our packages is to use R in its development version, which is it's really full of bugs. It's true. So the main idea is that while you are developing your own packages, you contribute to the R community to fix their bugs if you find any kind of bugs in your code or in any dependency that you have from your R package. This is because not just for that, it's also because when you are releasing your R package, you are already on the latest version of R, so that the development version will be the next release stable version of R. So, and everything will work smooth in this way. And finally, your work is never done because you will have continued bug solving and also maybe some broken dependencies along the package life. And this is a suggestion to keep as much as possible, of course, your dependencies as small as possible. So in this way, you have less dependencies to fix during the lifetime of an R package. Here, I just put several links for compiling or for installing R development version on Linux, OS X, and Windows. But of course, if you don't want to use R development version, at least use the latest stable version of R. So in this way, your code is not so old because if you are using an old version of R, your package is already old. And so you have to keep it updated even the day after you are releasing it. So thinking about CRAN, okay, the Comprehensive R Archive Network. So this is the repository, the official repository of the package of the R packages. There are other repositories, like the one for the biological packages, the bioconductor, and also it's plenty of packages on GitHub, and you can install that packages, you can depend on that packages, but I would not suggest that if you are releasing an official package, because all the packages that are on GitHub, they are not tested. So you risk that you depend on something that it's broken, and you can include bugs already in your package, in your total new package. So as much as this is possible, of course. So thinking about writing a new package, there are several guidelines. This is a huge manual of guidelines for developing our packages. I will share the presentation later inside the GitHub repository. And so the main idea is that you give an overview of these guidelines, but it's really huge. You cannot read the entire guideline. I understand that. So while you are working, you just keep in mind how to write the code, because if you want to go on cron, for example, there are some specifics that you have to respect to go on cron. So passing all the checks, all the tests, and some other stuff. And we will see some of these later. And so I think that the good part is that now cron has been improved a lot. 10 years ago, it was not like you have cron now, so it's organized in microthematics. You know which packages are included in one thematics respect to another. So, and this has been done all from the tidyverse people. That some of these people is in common with the RStudio people, so they are everyone is involved in the same big community. Okay, so about RStudio, maybe most of you already know RStudio. It's an integrated development environment dedicated to R. On the internet, you can find several IDEs. I here point out that this is not the best IDE, but as a software developer, because software developers mostly work with multiple programming languages, multiple infrastructures. So other IDEs are better because they have very much more features. But if you have just to write R code or doing analysis with RStudio, it's enough, even more than enough for what you have to do. And so, as you maybe know, is organized in 4 different macro areas, and we'll see this in a couple of minutes. And it gives you a creation of our package skeleton in a very easy way. Also the support for the documentation, rmarkdown, code versioning, integrated plot visualization, and also it recognizes other languages like these ones. For example, mostly we will see YAML files today, and no, just this one. JSON also is recognized, but we will not see that. Maybe you can include some C++ source code in your packages, and this will be totally another couple of lessons on that. So it's good, and it's the other good part of RStudio, it's daily released and developed. So every day you have a new version of RStudio that you can download and install in your machine if you want. Okay, so now we go already on if I'm able to do that. We go to the RStudio and see that I can hide again this one. Okay, let's start by a simple script. If I have a script like this, I can also put some plus here. Can you read it? I don't know. Why is it like that? Maybe I can do something like, where is Zoom again? Legend. Okay. Otherwise we can hide that and we can, okay. Okay, we start by loading the cars dataset. For example, it's just the first dataset that came into my mind. And so we just subset this dataset and we save this data somewhere. We just saved the data in this data folder and we keep that apart for now. And we want to transform this data in some way. In this example, we just compute the mean of this vector, which is a numeric vector. And as you can see, we compute the mean by hand, and we can verify that the mean provided by the RBase, it's the same. So at this point, we can think, okay, but I can write a function to automatize this process. Of course, this is very simple code, but think about you have a much bigger algorithm and you are copying and pasting that code several times. You don't want to copy and paste because it improves. So it could bring several bugs, and if you find a bug, you have to fix that bug several times, and you have to find every line of code where that bug was. So at this point, we just do a function, myMean. Thanks to even to this simple function, we can check the inputs for our function. and then we can apply our transformation of the data. In this case, we just compute the mean of this numeric vector. And in the end, we return that value. Starting from this very simple example, I want to create an R package because I want other people to use this function. I don't want just to use by myself. And so with RStudio, there are several ways of doing R packages skeletons. For example, we have, I think here, we have this function of the utils package, this other function of the usethis package. But we are very lazy people, and we prefer to do something like this: new project, don't save my workspace. And we select new directory. And so in this way, we have several skeletons of different R packages that we can create, packages or projects, because there are also other projects that we can create. We start from a very simple R package. We give a name, my package, and we already have some source files because we have that function in the mymin.r file that we want to include inside our package. And so we can do that by going here and scripts, no, R. We include this and these other, let's start by this. We will see that later. We can also create a Git repository, but I will not create it right now because I want to guide you through the entire process of creating a Git repository by hand later. So we start just by creating this new project. And here, this is the basic skeleton of an R package. We have a description file, the namespace of our package, the rproj file that is just an RStudio file. So if we don't use RStudio, we don't need this. The man folder where all the manuals that we are going to write the documentation of our function will be. And as you can see, there is this R folder where the R script has been already saved. And also there is something missing. So we want also to export some data. And we already prepared this data briefly before. And to export this data set from your package, you just create a data folder inside your package. And with this data folder, you will export this data set inside from your package to any user. So when you do data cars, there is a package where this folder is being saved within the cars.rdata file. Okay, so I think that, 2 words on the description file. So the description file is, of course, the main representation of your package. This is just the name of the package, the type of the package. The title, it's a little bit more, it's a little description of your package. So we just say package for computing mean of a vector. And who wrote it? The versioning of your package is related to every time that you reach a milestone. So a point where the package, your package is okay, it's working, it's functioning, and you want to save that, you just keep this version updated. And maybe a good thing is to use also a news file. For example, version v10.010, and we want to say, okay, in this version we started our package, and we can save this inside our package as the news file, for example, and keep an eye on the versioning in the extension, in the guidelines that I pointed you before in the presentation, because there is always some specifics for this versioning, depending if you are on CRAN or other repositories. Who is the author? So it's me in this case. And who is the maintainer? Also me in this case, because you can have multiple authors and you want just to define one single maintainer. Let's use UniPD in this case. And also for the description, here you have a bigger description of your package. And this has to be more than one phrase. So we copy and paste this one. And we tell with a comma that it's more than one. Let's leave a comment. We will see it later, just to give you an idea about the checks. Here, the license, I selected just an MIT license, and I'm also pointing file license, file plus file license. Let's see. This lazy data, I'm not sure what it is, but it should be something to be some sort of caching of your package by R. The encoding, it's always UTF-8, and there are 3 others very important tags here, which are depends. And with depends, here you will include all the packages that you are depending on. So all the packages that if you don't have those packages, your package doesn't work at all. Okay. Then we have imports, and this is the list of the packages where you are importing some functions. So for example, I'm importing just the ggplot function from the ggplot2, and I have to specify here ggplot2, for example, inside the imports. And finally, there is the third tag, which is the suggests. And this is the list of packages that you are suggesting to install, because maybe you are using them in your use case or in your big net or in some, but if they are not installed, it's not a problem because your package will work anyway. Okay, so we have everything, and we can go back to the presentation. If you have questions, just ask me. And here we have this package, which is the devtools package. This package is really useful. This is just these 4 functions here listed, but it's plenty of functions that helps you during the package development. For example, the load all function, when you run it, it loads your package if you are working with it. So you can test your functions that you are just exporting from your package. You can try to install the package on your machine. You can build your package as a tar.gz file that can be exported or moved to other machines. You can check that it passes all the checks needed to be installed. So it's plenty. There is also the document function, which reads all the documentation that you wrote, and it creates all the manuals for your package automatically. Finally, there is the test function, which takes all the tests and will test the unit tests, and we will see this later. And you can also install with GitHub packages with this function. Then we can use, for example, the Oxygen package for writing the code, for writing the documentation. So the documentation is one of the not so nice things to do while developing code, any kind of code, but it's the most important thing to do because it helps other users to understand what you're doing, but it helps you to remember what you have done. Because in a couple of weeks, in a couple of months, you will never remember what you have done inside that function. And so the good part is that nowadays, Oxygen works, first of all, because at the beginning I used the Doxygen with C++, it didn't work at all. So now it works very well. And it interprets this sharp Python as a tag for the documentation that you are going to write. And also the @ specifies all the keywords that this package has to interpret as part of the documentation. And RStudio helps you to write a skeleton of the documentation of the function. So you don't have to do everything by hand. And together, Roxygen and devtools auto-generate your documentation files. And this is the best thing that you can, come on, let's hide again. Okay, so going back to the RStudio, which is always better, we can insert a documentation skeleton for this function. We just use this magic wand, and we can say insert Roxygen skeleton. And here we have our skeleton. We can just populate it. We just put the name of the function. We can also add a description. And with the add, I'm adding a new tag. So add description, and my description, I already have it here, for example. And here you are specifying all the parameters that you are passing to your function, you define for your function. So you know that this vector has to be a numeric vector. And return, what does this function return is just the mean, a number indicating the mean of the input vector. Export is an important keyword because when you are writing a function, if you want to give the possibility to an external user to export, to use your function, you have to export this function. And by doing this keyword, Roxygen 2 automatically interprets that this function has to be exported, and it includes it inside the namespace. So this namespace file, it will include all the functions from external packages that you are importing in your package, and all the functions that you are exporting outside your package. And the good part is that Roxygen 2 will take care of this for you. You just have to put the just keyword, the right keywords here. Finally, another thing that is really important is to write examples. This is really boring, but we already have some data. We have data subcars. And we know that x equals subcars $speed. And finally, we know that we can print the output of my mean of x. And if everything goes right, it automatically will test also your examples. I will give you a very brief example of an internal function, because there could be some functions that you don't want to export to the external, to the outside your package. So typically, a good way to do an internal functions is to use dot and the name of the function. You just specify the function as any other kind of function. You just put some code here. And it's good to write also the documentation for your internal functions, but we will not do this right now. We can also decide to not export this, and we want just to specify that this is keywords internal, because we want just to use this dot internal function inside our package, inside our other functions, but we don't want other people to use it because it's not really useful. So at this point, we can start with the devtools and say library devtools, and we can start by doing the documentation and see if everything is, we wrote everything right, and if the documentation is created. So it wrote my mean.rd file, which is here right now. So we didn't have to write this manually. And the namespace hasn't been written because it says I already found a namespace. I don't want to override it if you don't tell me otherwise. And so we can just remove this. We don't care about this format. And we can write it again. And we can see that the namespace now exports our function. I mean, what if we want to import a function from another package? Also, we can specify this inside the documentation. And we just say import from, I don't know, ggplot2, the function ggplot. I'm not using it right now, but for example, we can do that with just document. And the namespace has been updated with the function that we are importing. But if I do a check on my package right now, let's check if everything is okay, thanks to the devtools, we will have an error. It should give an error. Okay, so dependency missing from the description, imports depends entries ggplot2. So we have to report the package inside the imports ggplot2 here. And if we check again, we should have that everything was right. The last thing about the documentation is about the data. So we are exporting the data now, so a data set, but no one knows that we are exporting the data except by us. So they suggest inside the guidelines undocumented code objects. So we have to document our data. So the fact that we are exporting our data sets. And to do so, we just include, I already prepared this, of course. This data.r file, which I'm going to include inside my package, inside the R folder. Let's open the data. And as you can see, I already wrote the entire documentation for my data set. And I'm specifying that the data set is named subcars, which is the same name that you can find for the file here. So in this way, you already have everything that goes right. You can document. It writes the manual for the data set, and we can check, and everything should go okay. While it checks, we can go back to the presentation and say that it's okay. I documented everything, but I documented every single function that I have inside my R package. But how do we combine multiple functions if I have that one function depends on the output of another function that I created before? So you have to create a vignette, so a report, a simple report, a use case of how to use your package. This also, in this case, helps you to remember how to use your package, and other people how to use and combine the functions included in your package. And we can also use the session info at the end of the vignette, because we want to take track of all the packages that we are using inside our vignette. And there is a bonus package, which is the usethis package. It's already imported from devtools, and we can use already its functions. And these some of these functions are, I have a script for this. Use this. So we want to create the vignette, but we are very lazy and we don't want to write, open, and do everything by hand. So we just use this vignette function, use vignette, the name of the vignette, and the title. So, and it automatically creates the vignettes folder and a new vignette to be used. This is the YAML header for this vignette, and you specify all additional information, visualization in particular, visual aspects of your vignette. There are several templates that we can use. We are interested in using HTML document because, for example, it can give us to use the table of contents, for example. You can also specify several other tags here, the author, the time, and several other stuff. And this is what I was saying, that we can mix. So the rmarkdown file package, so it's a markup language, and we can mix natural language together with the code. And rmarkdown allows you also to mix different languages, not just our language, but you can also create code chunks for Python and some other kind of codes that you want to include there inside. But they have to be script languages, not programming, not languages that have to be compiled. So first of all, we just load stuff, for example, and here we import our package and dataset, and here we say data subcars, and here we use main function of our, we can do my mean of subcars $speed. And here we can just specify I'm computing my mean and comparing with the base mean. So I print my mean here. I print the mean here. And finally, I will add a session info withhold session. Oh, sorry. And at this point, so we modified as just suggested. We can check our package again, and it will write, hopefully, our vignette if everything was written rightly. And indeed, it created it, I suppose. Okay. The vignette is not compiled and included in your package because it will be compiled on the fly when your package will be installed on another machine. So you will never take trace of your compiled vignette. So we have a warning, but we can take care about it later. We will see this later because we don't have so much time. So, okay, so now that we wrote also a vignette, we are interested in test our code. So it's important to test our code because we create simple unit tests for our code because we want to, so let's imagine that we deployed our package. People are starting to use the package and they find a bug somewhere and we have to fix that bug. But we know that by fixing the bug, we don't want that the output of our functions changes because we know that the output has to be in that format or some other stuff. If there is not, if the bug doesn't affect our output. So when we are going to change the code of our functions, we want to be sure automatically that everything is not affecting the final results of our package, and our function. And to do so, the tidyverse people, of course, developed this testthat package, which helps and exports several functions to test different types of output. For example, expect true, if you are expecting for a variable for an output to be a true or false, expect false, expect is, expect equal, etc., etc., etc. So also in this case, the usethis package will help us to create the entire skeleton. And exit full screen. We can also in this case use testthat to do so. So we use testthat, and as you can see, it created this tests folder. Inside these, we have this testthat.tar file. Inside this file, it's already taken care of loading the libraries necessary to do the tests, and also telling to testthat that it has to test check your package. And here in this other subfolder, there will be all the files that are going to include your tests, your unit tests. And if we want to do a simple test, we use this function, usethis. We just go inside our function, myMean. We put the caret here, and we just say this, and it created the file. We just have to modify and populate it. So this is a very standard, most application works, for example, but this just give you the idea. myMean works, and we want to test that data subcars x equal to subcars $speed, and we want that myMean, so y is equal to myMean of x, and we want that y is equal to the mean of x. So we want to test this. We just run tests, and we got that it's okay. So in the end, this was the right output, and our output of the myMean is equal to the mean that is exported by the base R, which is what we were expecting from the beginning. Okay, so let's go ahead and let's start talking about Git and GitHub. So as you saw that we have done all these document, check, test, all this kind of stuff. We have done it manually, but thanks to GitHub and GitHub Actions, we can automate all this process. But let's start by talking about GitHub. So GitHub is not Git for the ones that are confusing these two aspects. So Git is the main software. It's installed on your local machine, and you can create Git repositories for each kind of projects you want to take versioning of. So we can initiate a Git repository with git init. You can create a local repository for your R packages, one for each R package, your thesis, your CV, any kind of project. And I suggest to not keep track of data, because otherwise GitHub can ask you for money. And so it starts to become things very complicated. So just keep track of very light stuff like text files. And so once that we created a local Git repository, we can create a remote repository. So and we can use GitHub or other services, because GitHub is just one of these services, online services. And on GitHub, you have multiple repositories if you want. And you can link your local repository to the remote repository. And this helps in the end to also the team working, because first of all, you have a copy of any work, any projects you want on the cloud. So if your if your laptop goes on fire, you have everything saved there, even your thesis. And also about team working. So we are working together on the same project. We can push and work on the same file, and we can propagate our changes on the cloud, so on GitHub. And GitHub will take care of this. If we, maybe, for example, if we are working on the same line of codes and we change the same code on the same file, GitHub will say, okay, there is a conflict and you have to take a decision about which code to keep, yours or your colleagues. And you have to discuss with your team workers which is the best code to maintain for that code chunk. So even if you are by yourself on a project, it's good to use a local Git repository. You will keep version of all the changes that you are going to do along the time of that project. And by doing so, this means that if at a certain point of your work, you are saying, okay, it's broken, it doesn't work, but yesterday was working, I can go back. So I can go back and erase all the bad changes that I've done. And also, speaking about Git and GitHub, we can spend days about all the functionalities and all the things that you can do with Git and GitHub. And so for now, we will just have a brief overview of this. And so our studio will help us also to do so. And let's see how can we do this. So here I put just the basic commands for taking track of the changes inside your repository. And again, let's go back here. And first of all, it's better to go here. So let's go on GitHub. We have already an account and we create a new repository. There are several ways of doing this. We just can use this or whatever we want. You can also already give a template to your new repository. We will not look into that, but just to give you an idea. So repository name, my package. The description, if we want, if it has to be public or private. If it's private, you can invite collaborators and share the code with them. If it's public, everyone can have access and read the code, but not interface. But they maybe can fork your code. So they can create their own repository on their own GitHub for that public repository. The license, we will not put any of these because we just want a blank repository for now, and we want to propagate every file that we have on our machine, and we want to propagate on the GitHub later. So let's create the repository. And we see that here we have this new name for our GitHub repository. And GitHub gives you two possibilities. You can initiate the new local repository with these lines of code, or just use these other ones if you already initiated the repository on your local machine. We just start by doing this. So first of all, it creates a README file to describe what's inside your repository, what's your project, or whatever. The git init initiates the GitHub repository, the git local repository, sorry. And with git add, we tell to git to take track of that file, of the changes that are doing for that file. So let's start by using this. We use the terminal. So, and as you can see in this part of the panels, we have also the terminal of our machine. So RStudio helps us also in this way. We just create this, enable, nice. Why? Okay, of course, it's something that I cannot do anything. Let's go back here. Downloads, our package, devel, my package here. Okay, so it's the same. Sorry for that. Of course, something should happen. So git init, and we just initialized our empty git repository for my package. We can use this git add readme. Okay, because also the echo didn't work before. Okay. So we can add this readme and tell Git to take trace of this, and we want to understand the status of our repository. So we just say git status, and we see that in green, we have all the files that we are tracking with our local Git repository. And in red, we have all the other files that we are not tracking, still not tracking. But we just told to Git to keep track of that file, but we didn't add the changes to the Git repository. So to do so, we have to commit our changes to the Git repository, and we can use this git commit -m, which means minus message, first commit in this case, but typically it's good to have, after the first commit, to have very informative messages, in particular if you are working with teammates. And at this point, the Git branch, I will ignore it for now. I will, with this particular message command, I'm saying git remote. So I'm talking to git local to add a remote, so a cloud repository. And we call it origin. So add a new remote on the origin, and we specify the link of this GitHub repository that we just created. And then we can push this, the master, because in our case, the branch, we can talk about the branches of Git for hours, but we will just take this as the best that we can do. So we're just pushing our master branch, which is the branch where we are keeping track of all our files, on the origin, so on the remote repository. And here we just uploaded the README file here. But we still are not keeping track of all the other files, and we want to do that. And to do so, we just have, sorry to go back and forth from the console, but we can just say git add asterisk. I'm adding all the files, these red ones, git status, and see that it added every file here in green, but it didn't put these red files because these are hidden files, and you have to specify to keep track of hidden files. So we just add these files. We just give a new commit, git commit -m message first commit for package. And we just push on the remote this information, all these files. And now we have them also on GitHub. If we don't do the git push, we don't have these files here. If someone changes the files on the GitHub, we have to do a git pull on our local repository. So let's imagine that a team worker changed this my main function. I have to just do git pull before starting to work on my repository. This time is already up to date, of course, because I just pushed everything. But generally speaking, before starting to work your new day of working, of coding, you have to just pull everything and then start to work and see if there are any conflicts and if you can start to work on that repository. If you are all by yourself, it depends. If you have multiple computers, for example, you just push it from work from your laptop at home, and you go back to work, and you have another laptop. You can pull everything from home on your laptop and work from your office on the same code that you propagated in this way. Oh, sorry. Okay, finally, another nice thing about the GitHubs. Sorry for the Photoshop that started by itself. We can use the GitHub actions, which right now are pretty common to use them. And this is an instrument, a feature. There are several of this stuff nowadays, but this helps us to not do all the checks for our package by hand. So we can just start to work on the code, and then we decide to push everything on GitHub. And thanks to the GitHub actions, it automatically creates a virtual environment still on GitHub, so you don't have to keep your laptop busy by doing all this stuff. And so on the GitHub, it creates a virtual environment. So let's imagine a Linux machine on the cloud that has been created on the fly. Inside this Linux machine is installed. All the dependencies of your package are installed. Everything, your package is installed, and then your package can be checked, built, and all the things that are needed, and you decide all the things that could be needed for your package to be done. And for example, you can also deploy your package outside GitHub. So you can say, I want to create a Docker image. I don't know if you're familiar with Docker, but Dockers are specific objects that are auto-enclosed virtual environment inside a singular image object. So you have, for example, a Linux image inside this object. And inside this object, you already have everything you need to start with some analysis or to repeat an analysis, for example, the data or the code or whatever you want that. And this also helps very much the reproducibility of something, because you are putting there a milestone of your analysis with all the package needed for that analysis. And you are fixing all the versions of all the package that you used during that analysis. And even in 10 years from now, that package, that Docker image can be installed on a machine and can be done, and all the analysis can be done again from zero, and you will obtain the same identical results that you obtained while you were doing your analysis 10 years before. And finally, for example, this is just a few examples of the things that you can do with GitHub Actions and what we typically do. But with, for example, with package down, this is another R package that helps you to create websites. You can also deploy your own website in this way. You just create the website with the package down with some code. You put it on the GitHub, and it automatically propagates it on a GitHub.io page, and you have your own website available for your CV, for example, for showing your CV or your position or whatever. And at this point, this is the last thing. I've done this again. Okay. We can go on. Okay, so let's go on GitHub and see that here we have this action button. These are this is the feature inside GitHub. And as you can see, for now it's empty. It suggests you some actions that you can include. The actions are nothing more than a YAML file where all the steps are described. And some of these actions are already present on the GitHub, but of course we want our workflow to include. And I prepared this before today, and here it is. This is a basic checks YAML file, and we want to include this in our package. There is a specific location for this file inside your package to be read by the GitHub, and here we just create a new folder .github. Okay, yes, with a dot. Here we need a new folder, workflows. And now with Git, we just say git status. And here we have this hidden folder. We just have to add it by hand with git add GitHub asterisk. Git status again, and git push, git commit minus GHA workflow, git push. And now we have on the repository, we should have the workflow file. And if everything, okay, as you can see, this dot appeared. And this means that it's running. You already can see the dot here. It's associated to this specific ID for your commit. And here in the actions, you can see that this is the list of your workflows. In our case, we just have one workflow. You can add as much workflows as you want, so as much YAML files as you want. And here it started to create all the steps that we included in the workflow. If you want to, we can just briefly have a look to this file. It's plenty of documentation. It's so huge that it's very difficult to understand everything still for me. And so here we have just some tags, and for each of these tags, you can specify specific attributes. You can, and here with jobs, you just specify which are the jobs that it has to execute. Also building a package down, for example. And if you want to have, it takes a lot of time. The good thing is it's not running on your laptop, on your computer. So you can do whatever you want in the meantime. At the same time, so if we do a check here, it takes time and it can slow our computer. But if we just push our changes and see if everything goes right, the checks are all taken care of from the GitHub Actions, and we can do whatever we want with our computer. And for example, we use this several times. For example, for this workshop, we included data, we included code, we included packages, and thanks to the GitHub Actions, they are still there because we executed these specific workflow file. And just to give you the idea, we can do that. Okay, so this is the website automatically deployed with the package down and the GitHub Actions. So we have a website for this specific workshop that we made during a conference. And together we have all the articles, so the vignettes, the use cases that we presented at that specific workshop. And also we have still the Docker image with all the code that we presented at that specific workshop in the 2021. And you can just, if you have Docker installed on your local machine, you can just Docker pull and execute that Docker image on your machine and replay and repeat all the articles that you have here, for example. So here, this was just introduction, the oral introduction, but here you have the code and you can execute it inside the Docker image. And this works. That's the most important part. So, and this is the main overview of that I have for you today. So remember that we have also this bonus package, they use this, which could be, and it's plenty of functionalities, so you would just have to explore them. And that's it for today. Perfect in time. If you have any questions, otherwise, if you don't have questions right now, we can also discuss it later or via an email or whatever. That's it. Thank you.